Good morning, students. Hope you are safe and sound at home. Hope you are safe and sound at home. Students, you saw the previous videos of this chapter, lesson number 9, Geography, the Earth, our habitat. Now, students, we come to the next topic over here, that is types of motions of the Earth. In the previous videos, we saw how the Earth rotates on its axis. Okay, so we studied what is axis, what is rotation and revolution. In short, we have studied in the previous videos. But today, we will be studying it a little more in detail. So first we will see types of motions of the Earth. Students, here motions means the movements, how the Earth is moving in different positions. Okay, so in your syllabus of 6th standard, you have two types of motions of the Earth. First is rotation and the second one is revolution. Rotation and revolution. So students, both these terms will be studying in detail. First one is rotation, second one is revolution. So students, let's see the first term. The first concept is rotation. What is rotation? Okay. Now students, you all must have seen a top. You all must have played with it in your childhood. Top. It rotates on a single point on its axis. That point, that specific point on which that top is rotating, as soon as you touch it and spin it, it moves in a fast motion. That motion is called as rotation. Rotation of the top. That same thing you have to imagine for the Earth. For example, as we saw in the previous videos, this is our axis. If you rotate this chalk in this way on this point, it is known as rotation. For example, this is an axis. Now students, I have already told you in geography, all these things are imaginary. Lines, measurements are all imaginary. And you have to imagine this as the Earth, spherical shape. Okay. So this is the axis of the Earth and this is the line, the point on which it is rotating. So this part on which the Earth is rotating is known as axis. So just like a top rotates on its axis, in the same way the Earth also rotates on its axis. This is the imaginary Earth. Okay. And you know already the shape is spherical, just like a sphere, like an orange, not like a ball. Okay. So the Earth rotates on its own axis from west to east direction. Which direction, students? From west to east direction. Okay. And this motion, this circular motion is known as daily motion or rotation. Again, I repeat, students, what is rotation? Rotation is also known as daily motion. It means just as a top rotates on its own axis, in the same way the Earth rotates on its own axis. All these figures are imaginary, all these terms are imaginary. In reality, you cannot see any axis on the Earth. Where will you see the axis? It is imaginary, okay? Only for measurement purpose we are studying in geography. The Earth rotates on its own axis and that also it rotates from which direction? From west to east in a circular motion. That is known as rotation. The other term used for it is daily motion. So, the Earth completes one cycle or a single cycle of 1670 kilometers per hour. Okay? Okay, students, the Earth completes one cycle or one rotation of one single rotation, that is 1670 kilometers per hour on equator. So this can also be written in this way, students, 1670 kilometers per hour. Okay, in short, I have it this way, 1670 kilometers per hour on equator. Okay, this is the one single revolution. This is the single revolution. This is the single rotation which the Earth completes in one single time. That is 1670 kilometers per hour on equator. This takes 24 hours. That is one day. So one cycle of rotation is equal to 1 day. And 1 day means, students, what? 24 hours. Okay, students? Clear with the topic here? Yes. It means one rotation of the Earth, one cycle of rotation takes 1 day. It is 24 hours. And this period is very important in the changing of days and nights. And this is the main factor responsible for your changes of day into night and night into day. For example, if we have day for continuous 2 times, it's not very easy to understand the concept. Why? Because after the day we need a night. After that again a new day. So that cycle has to go on. So for that to go on, you need rotation. So this speed of the earth rotating in this speed, that is 1670 kilometers per hour, is very important for the changing of day and night. And the shape of the earth, that is, each of the shapes, friends, yes, you already know the shape of an orange, not like that of a ball. You have seen the previous videos. That shape is obtained by the earth due to this rotational speed. This speed is very important for that shape of the earth, that is the shape of an orange. So students, what did we see? That the earth rotates on its own axis. That is the rotation. That concept is very clear with you. Now, just see this globe. You already know the globe is the replica of the earth. Okay. So this you have to consider as the axis. Okay. The earth rotates on its own axis. See students, the way it is rotating. Okay. So this way, this axis is the point on which the earth is rotating. All these things are imaginary, students. Already you know it. So the earth is rotating on its own axis. One cycle, that is one rotation, is 1670 kilometers per hour. And this speed gives it the shape of an orange. Okay, students? And this is known as one daily motion or one rotation, one cycle of rotation. So students, here the second concept of motion of the earth, that is revolution. The first one was rotation, second one is revolution. What is revolution, students? Earth revolving around the sun on its axis. Okay, that was rotation in which it was moving around on its own axis. But here, this is revolution in which earth revolves around the sun on its own axis. Okay, so in this way, one revolution takes 365 days. So students, 365 days means 1 year. Yes, correct. Okay, 365 days means 1 whole year. So, one revolution means it takes 1 year to complete one cycle of revolution. That is, the earth moving on its axis or revolving on its axis around the sun. The earth revolving on its axis around the sun is known as revolution. And that takes, one cycle of revolution takes 365 days or 1 year. And this is an imaginary term. Okay, all these concepts we studied about the measurements and all, latitudes, longitudes, all these are imaginary terms. Only for measurement purpose we are using it. So this revolution takes place in an imaginary path or way. This revolution takes place in an imaginary path or way. Okay, that path is known as the orbit, and that is in space. This imaginary way is in space, that is known as orbit. Okay, the name of that imaginary path is orbit. Orbit is the way, the place you can say through which the earth is revolving on its axis around the sun. And distance between sun and earth is not same throughout the year. Distance between sun and earth is not same throughout the year. Not same throughout the year. Why? Because of revolution. Yes. Why? Because the earth rotates on its own axis, that you know, but it creates an angle of 23.5 degree on its axis and 66.5 degree on its orbit. So students, let's see the earth on its axis rotating around the sun. So this earth, here you have the sun, you can take any position. Here you have the sun, is rotating around the sun. It is rotating in this way, okay, revolving around the sun. So this is known as revolution. In rotation concept, what did we see? Only this earth was rotating on its own axis. No object was around it. But here in revolution, the sun, whichever position you are taking, suppose this area or this area, the earth is rotating on the axis around the sun the whole year in this manner. Okay. So one circular motion takes how many days? 365 days. Okay, students. So what happens due to this revolution, students? This movement causes the rotation of the earth on its own axis, causes the creation of angles of, first get the angle of 23.5 degree. This is on the axis. Okay, this angle is towards the axis, and the second angle is 66.5 degree towards the orbit. Next angle is created at 66.5 degree orbit. Orbit means what, students? The path on which rotation is being done around the sun. So this is the meaning here. 66.5 degree orbit. The angle created is 66.5 degree, and for the axis the angle created is 23.5 degrees. Now we'll come to the next point here, that is, because of this revolution, the changes in seasons is caused. You know, students, what happens because of revolution? We have changes of seasons, that is rainy season, monsoon, summer, winter, autumn, spring. Seasons are changing according to the revolution of the earth. And days and nights are also extended or shortened. Days as well as nights are extended or shortened. Anything can happen, okay? For example, in winters what happens? You have nights, long nights, and days are small. And in summer, nights are short and days are long. So all these phenomena occur because of revolution of the earth, that is seasons, seasonal changes, and changes in the duration of day and night extension or shortened period of nights is also occurring due to revolution. So we'll come to the next topic, that is day and night. Students, day and night is a normal natural phenomenon which has to occur everywhere around the world. Why? Because continuously daytime or continuously nighttime is not possible at all. God has created the universe in this manner only, that one day, then one night, it goes on like that, okay, in a continuous series. So, due to the daily motion of the earth, students, what is daily motion? Yeah, rotation. Because of rotation, what was occurring, students? Which phenomenon? Because of rotation, we had the occurrences of days and nights. Because of rotation, you have day and night phenomena, okay? And due to that, what happens? We have one day, then the next, we have the next night there, again the day, then the night. So it goes on, the series continues. So the earth experiences days and nights because of rotation, that is 24 hours a day. And the earth is tilted and rotates on its own axis. The earth is tilted towards one side, that we saw in the previous videos. The earth is tilted a little bit on its own axis, it rotates on its own axis. So if earth would not have rotated on its own axis, then what happens? One side would be always light and one side would always be dark. So to avoid that, in nature, it's given by God that earth should rotate on its axis, due to which what happens? Every part of the earth receives both day as well as night. Okay, students? So, the imaginary terms, rotation and revolution, has to be understood by all in this manner, that if rotation does not take place, then only one part of the earth will get light always and the other part will always be dark. So due to that, due to rotation, what happens? All the parts of the earth get equal light and darkness in every 24 hours. Okay, and this phenomenon causes morning. We have experiences of morning in every part of the earth. We have experiences of afternoon, evening, and night. All these 4 times of the day is experienced by every part of the earth. Why? Because rotation takes place in one cycle, that is 24 hours. One rotation is equal to 24 hours or one day. So differences in length of day and night is also there. Just as we saw, in winters we have long nights and short days. In summers we have short nights and long days. So all these things which occur, that is morning, afternoon, evening, night, and change of day and night, and duration of day and night is due to rotation. So students, will come to our diagrams. Start drawing this diagram along with my notebook, students. This diagram is day and night. Just now we saw day and nights occur. Days and nights occur due to rotation. Okay. So we'll draw the diagram of day and night. Now students, you have to draw the circular part of the earth. You have to draw the spherical earth in this manner. Not exactly round, just like normal. You have to draw. And the sun. This side you have to draw the sun. Half the part. You have to draw only half the part. And shade it in this manner. Only use your pencils, students. Okay? Use your pencils, shade it and write down your sun. Okay? Now, it's quite a natural phenomenon that sun rays fall towards the earth. So students, you have to make the sun rays fall towards the earth in all directions. Okay? Start making the sun rays, students. You have to point arrows towards the earth. Okay? Point the arrows towards the earth till the ending. Okay? And what are these students we are drawing? We are drawing the rays of the sun. Okay? Draw the rays of the sun and we have to point arrows towards the earth. Okay? You have to point again over here to show that the sun's rays are pointing towards the earth, falling towards the earth. Okay? Point at the arrows? Good. Now, after that, as usual, as we drew the previous figures in the same way you have to divide the earth into half. That is 90 degree north and 90 degree south. North pole and south pole. But in this diagram, just now we saw in our topic, what was that? Earth is slightly tilted towards its axis. So you have to draw the tilted angle in this manner. Okay? Tilt it in this manner and see to it that you write 90 degree here, 90 degree here. And what is this? 90 degree north, 90 degree south. Now students, this is the way the earth is tilted. So the normal latitudes which you already know, you have to label it first. So start labeling along with me, students, with your pencils. Use pencils for labeling. Don't use pen, students. Start labeling. First you have your equator towards the central part. 0 degree is your equator. So write down equator. You can write through the lines, students, no problem. You can write through the lines. Equator. Then you have your 23.5 degree north. What is that, students? Tropic of Cancer. Then you have your 23.5 degree south, Tropic of Capricorn. No need to write latitudes and all, only the degrees you write, okay? North and south. Because we are showing the days and nights. Okay, we are not going latitudes exactly, we are showing the day and night phenomena. How the sun rays are falling towards the earth. Okay? Then again you have your circles. Which are those? You have your South Pole circle and North Pole circle. So 66.5 degree north, North Pole circle. You can write through the lines, no problem. And here again you have 66.5 degrees south, South Pole circle. Drawn, students? Okay? So students, as you drew the arrows here, so whichever part of the earth receives the sun rays or the sunlight, that part is known as day. Yes, nice. So which part is receiving light, students? The sun rays are falling towards this part. Yes, correct. And this part is not receiving. So this part you will keep it as plain. Why? Because it is daytime over here. And the opposite direction towards the sun, that is the place where the arrows are not pointing, that is this side. It is night. So we'll start shading along with in this manner. We'll divide it in this with the pencils. Give it a light shade, students, in this manner. Why? This shows that it is night time. Okay, this shows that it is night time over here. Now don't write over here. It will spoil the whole part. So here you write here as night. Why? This part is not receiving sunlight. Your arrows are pointing towards this part of the earth. Earth is tilted towards axis, we saw that. So this part is receiving light. And the area where you are having sun rays are falling is the day, that is it is having daytime. So here you write day. Put a bracket for both the concepts. Okay? Night and day. Understood, students? That is the area where you are getting the sunlight, where sun rays are falling is day. We'll keep it black in this manner, clay area. The area opposite to the sun's rays, that is this part of the earth, opposite direction. No sun rays are falling here. That part is receiving night time. Again it will be opposite. The earth is rotating. What will happen? The sun is there and its rays will fall this side. So this part will be receiving night and here this part will be receiving daytime. So in this way, one cycle or one rotation gets completed. Hope students have done this diagram very neatly in notebooks. Label it as figure 2.3. Okay students? 2.1 and 2.2 are already done in notebooks. Label it as figure 2.3. Okay students? So students will come to the next diagram here. That is long, short, day and night. We saw the duration of the day and night. The previous figure was only day and night because of rotation. Now how the duration of day and night changes. That is in winters and summers how they are differently having different timings. Okay. For example, in winters we have long nights, short days. In summers we have long days and short nights. How they occur, let me see in this figure. So students, this is your next figure which is very important. So start drawing this along with me using your pencils. Labelings are done with pencils. Now here students, you will draw the circular part of the earth in an elongated position. Okay students? Don't draw this in the form of an orange as we draw it usually. The spherical shape, will not draw it over here in this way. You will draw it in an elongated position and large position. Why? Because you are showing different phenomena over here. Okay? The central part of the earth, you draw the sun. Okay, you are focusing on the sun over here. And how many months are there in here, students? Yeah, 12 months. So students, first you will draw 12 circular portions which shows your different parts of the earth. How many parts? Different parts. And that also we are taking only for example purpose, 12 months of the year. So you will draw 12 circles. Okay? Start drawing along with me 12 circles. Okay students, little bit distance that you keep between each circle. Draw along with me, start drawing students with pencils. Okay? So students, draw the 12 circles. Hope you have drawn. No need to draw exact circular forms. Only for example purpose we are saying the 12 seasons. Okay? We are saying the 12 months. Okay? So start right from January. Yes, the first month is Jan. It goes till December. So we'll start labeling in this manner in such a way that March comes right on the top of this area of the sun and this month of September comes over here, right in the downward bottom position of the sun. You have to label it that way. Okay? So right here March and here you will write September. The bottom portion will write September. Now students, see to it that is start labeling. So Jan, Feb, March. Start labeling students. We can write the short form. Jan. I'm going to write the full name. Feb, March, April, May, June. See to it that June comes right in this position. Just like a clock, we have the hands of the clock. In that way, how we have the number 9 over here and we have number 3 over here. In the same way, June should come in this position and December should come over here. Okay? Okay, May, June, July. Go on writing along with students. August, September, you already written. October, November, and then you have your December. So students, 12 months are completed. See to it that your right angle you have your March and September, and this side position, horizontal position, you have your June and December. Okay? Gap of 6 months over here. So see to it that you are drawn in this way. Now I told you we are drawing the earth, different parts of the earth. So these circular portions are different parts of the earth. Okay? So you have to draw just assumption. I told you geography is full of assumption, imaginary things. So see to it that you draw in an assuming manner only. So just for assumption purpose, just make it in this manner, okay? As if we are focusing on earth. Just put in this way, just like an X, capital X, as if you are showing the earth. Okay students? For your better purpose of understanding, This way you have to just focus as the earth, different portions of the earth. Okay, for each part, each month, you have to focus in this manner. Okay, and see to it that all these are in equal ways. For each month, you will be having different concepts. Okay, now, firstly, what is the heading? So, long, short, day and night. That is extension of day and night in which manner? Duration in the northern hemisphere. Okay. Now, according to the natural phenomenon, according to rotation, according to revolution, we saw seasons change, days and nights occur, duration of days and nights change. You have different timings, different durations. The first one is 21st June is the longest day of the year. Which day students? 21st June. That is why right in this position I have drawn June. 21st June is the longest day of the year, and that is known as Dakshiniyam. What is that known as students? Dakshiniyam. So here you make a straight line and write 21st June. Okay, and that is known as Dakshiniyam. What happens? This is the longest day of the year. So here you have no space to write. So put an arrow over here and write longest day. Okay, students, written. This is the longest day of the year. Okay. Again, in the same manner this side, December. Just after 6 months, we have 22nd December as the shortest day of the year. This is the shortest day of the year. So you write 22nd December, that is the shortest day of the year. Just write shortest day, like you would there longest day, you write shortest day. Of there is understood for you of the year. Okay, and here actually Uttarayan falls on this day, but we celebrate Uttarayan on 14 Jan according to religious customs and traditions. But actually Uttarayan is the day on which you have your 22nd December. So put an arrow here and write Uttarayan. Okay? You can write Uttarayan over here and write shortest day over here. That's your wish. Okay, students? So this we completed. Now you have a new concept that is equinox. Okay, students, what is that concept? So now we have a new concept in this diagram, that is equinox. Students, what is equinox? E-Q-U-I-N-X. Equi stands for equal. Okay, equal length or duration of day and night. What we saw here, 21st June is the longest day, 22nd December is the shortest day. But here, equinox is a concept which shows that the duration of the day and the duration of the night are equal. Nothing is long, nothing is short. Days are not short, nights are not long. Not in that way. Day as well as nights are equal. How you will come to know that? This you will have to see in this manner. See students, draw the sun rays over like this. You will draw in the form of broken lines. Okay, don't draw slanting lines, not necessary here. Sun rays are to be shown. So just draw it in the form of broken lines. Okay, shadowed lines. March. Here you have your equinox. You have in the month of March the equinox concept. This term, what happens in this term? You are having same duration of day and night, and that falls on 21st of this month. No need to write March again because I showed you the month of March only. Okay, this falls on 21st March. The same concept you will have in the month of September. Okay, that is why we have drawn it in 90 degree both the months. Again, you have to show the sun rays in this manner. Broken lines. Again, you have the equinox. Okay, no, again it falls on 23rd September. No need to write the month's name because already we have shown in that month only. Only write 23rd. That's understood for you. So students, the concept of equinox is clear? Equal. Equinox means equal duration of day as well as night. No long night, no short night, nothing as such. Duration is equal. On which day, students? 21st March of the year and 23rd September. For every year, this concept remains the same. All these four phenomena remain the same for every year. Shortest day of the year is the longest receiving sun rays. So start drawing along with me for each month. Broken lines over here to show that sun rays are falling everywhere. Okay? To draw it everywhere for each and every month. Drawn, students? No need to draw it for these 4 months already drawing. Okay? So, for all the parts of the year, 12 months of the year, sun rays are being scattered equally. We saw in the previous diagram also. Earth is tilted on its axis, so sun rays which fall on one part, they are having day, and the other opposite part has night. In the same way, sun rays are having here 4 main phenomena in your textbook. We are having these 4 concepts. Equinox on 21st of March, 23rd of September, and shortest day we are having on 22nd December, longest day we are having 21st June. Dakshinya and Uttaraya here. Actually, we have these concepts in the next part of this chapter. The later stages will be studying it, but this diagram is very important for you all to see to it that you will draw it along with me. So students, I will draw this much. Label it as figure 2.4 students because we are drawing it up to 2.3, so figure 2.4. And the heading is long short daylight in the northern hemisphere. Now students, we drew the sun as the focal point, the focus is sun. We drew how the sun rays are going towards each part of the earth. So wherever you are not getting the sun rays, that area is night, yes. So those areas, that is the areas outside the circular portion of the earth or the sphere which are drawn, you have to shade in this manner. Why? Because you are having night. Only give the light shades to it to show the night time. No need to rub it in a very dark manner. Don't make it dirty. Okay, just show it in this manner. This area you are having night. Why? Because sun rays are falling only towards these areas. So rub it in this manner. Just move your pencils in a light shade. Don't make it very dark and make it dirty. Okay? Just see to it that you make it in a neat manner. Only lightly you will shade. Okay? So from this diagram, what can we conclude, students? That the sun rays fall directly on the Tropic of Cancer on 21st June. Sun rays fall directly on Tropic of Cancer on 21st June and on Tropic of Capricorn on 22nd of December. Okay? On 22nd December, sun rays fall directly on Tropic of Capricorn and on Tropic of Cancer on 21st June. Sun rays fall directly. And when the sun rays fall directly and the adjacent areas or the areas nearby to it, we are having long days and short nights. And when sun rays fall diagonally, that is in a slanting position, there what happens? Days are short and nights are long. Just like we showed you, see, here sun rays are falling diagonally, not in a straight manner. Wherever straight rays are falling, you are having daytime, and diagonal positions you are having night time. And the days and nights are of same length or equal length on 2 days, which are the 21st March and 23rd September. So students, we conclude this topic over here. We studied many concepts over here regarding the rotation and revolution, days and nights, and occurrence of seasons, and how duration of days and nights change. So students, go through your video very carefully, draw these diagrams along with me, label them with your pencils very neatly along with me in your notebooks. Diagrams which I am drawing, you have to draw along with me. They are very important from the examination point of view. Only then geography will be clear to you all. So draw along with me very neatly in notebooks. So students, page number 53 and 54 of your textbooks, read thoroughly to understand the concepts along with the watching of your videos. View your videos thoroughly so that when you read the